This is lesson 6.1, and I'm going to demonstrate the Alex homework problems. In the very first problem, we're asked to graph the two equations, and I have done that in the Desmos graphing calculator here. I've graphed the two equations, and we saw that the two lines cross at the point 1 and -7, and so there's only one solution to that. We saw the two lines cross in that one place. For number 2, for each system of linear equations shown below, classify the system as consistent and dependent, consistent independent, or inconsistent. In system A, we can see that the two lines are parallel. They will never cross, so there are no solutions. We call that inconsistent. In system B, we see that the two lines cross in one place. There are solutions, so we call that consistent. And because there's one solution, we call that independent. In system C, we can see that when we graph those two lines, they're actually the same line and they lie on top of each other. We call that consistent because there are solutions. There are infinitely many solutions, so we call that dependent. Type in the answers here. We have to look where that line, where those two lines cross at that point. -2 and 3. And then we will check infinitely many solutions for that one. In number 3, I need to graph the system and then write the solution. So for y equals 2x minus 1, the y-intercept is -1. And then I'm going to rise over run, 2 over 1 is the slope, up 2 over 1. There's my first line. For the second one, the y-intercept is -4. The slope is -1, so I'm going to go down 1 and over 1 to get the second line. And then we can see that they do cross at the point -1 and -3. For number 4, we're going to graph the system and write the solution. And for the first equation, we need to rearrange it into y equals mx plus b form. So I'm going to subtract 2x from both sides. And I have a y-intercept of 4 and a slope of -2. Slope of -2 is down 2 over 1. There's my first line. And for the second line, I'm going to start at the y-intercept -1. And I'm going to do the slope -1/3, which is down 1 over 3. And right there, I'm going to discover the point that is the solution to this system. That's 3 and -2. And in number 5, it says, Lena can choose plan A or plan B for her long distance charges. For each plan, cost in dollars depends on minutes used per month as shown. So if Lena makes 50 minutes of long distance calls for the month, which plan costs more? So the green line there shows you where those minutes are. And so we can see that the red line would cost more and the blue line would cost less at that point. The red line is Plan B. And then how much more does it cost than the other plan? We can look at the difference there between those. Between 6 and 12, it's $6 more. And for what number of long distance minutes do the two plans cost the same? We're going to try to find out where those two lines cross. And that happens at 200 minutes and $24. And if the time spent on long distance calls is more than this amount, which plan costs less? We can see that the blue line keeps going up further and the red line at that point is the one that's underneath. So past that 200-minute mark, we will want to choose Plan B.